with imine with water will generate Maillard. That is called 2,3 enolization. So the top here is 2,3 enolization. They are most likely contribute for the aroma. Okay. We finished talking about here. We finished talking about this guy. We finished talking about that guy. The fission products, volatile compounds, is all of a sudden will be created if the temperature is higher. So we have this reductone, dicarbonate. We also have that guy called pyrovyl aldehyde. Now we have another thing we haven't talked about. It's called Strecker degradation. What is that? Okay, Strecker degradation. So we're going to draw right here. That's on the top. Strecker degradation. So how Strecker degradation happen? Let's just draw an easy one. Okay, C. That is a reductone. Of course, I have all here. That is a reductone. It's a very similar structure to here or to here. And I comes with the amino acids. So what is the structure of amino acids? Let's go back to review. We have NH2, CH, O, and COOH. What is going to happen? The reaction. The reaction happening here is actually lose of water. Is the carbonyl group with this proton from the amino group, they will lose the water. So once they lose the water, they're going to be connected. How are they connected? Then become R. Then you go here, C. This is R, no difference. So you go here, you have N, C, R, H, and COOH. This is the intermediate products. These intermediate products came here. They will generate new products. The more important thing is this RC, this aldehyde. And they will generate ammonia. That could generate carbon dioxide, depends. And they could generate another, we call it combined hydroxy double bonds. Hydroxy reductone still comes out. But key thing with Strecker degradation is this aldehyde going to generate. Okay, so that's Strecker degradation. So almost done. More and more aldehyde accumulated, and with these imines, other products will have a polymerization, have more melanoid. We haven't mentioned one thing yet. We talk about one of the most important things for the bad characteristics of Maillard reaction is generally this guy, acrylamide. Okay, how we generate it? That is interesting. And I want to say this because this happens all the time. People know, but people doesn't realize it. How often in our lifetime? Okay. We can talk about acrylamide generation. Okay, what is a reaction? We need a D-glucose. So our glucose is right here. regular glucose, that's always a baseline. Okay, in a product, they are special prolific for one type of the amino acid is arginine. Okay, what is the structure of the arginine? That's why we want to talk. Oh, sorry, asparagine. I confused myself. Sorry, asparagine. And they have to be L-shaped. Okay, L asparagine. What it looks like? So we go talk about that is NH, CH, CH, COOH. So you have CH2, CH2 goes here, and H. That's asparagine. Okay, typically here. When this asparagine happens, what going to happen? Lose carbon dioxide, reacting with imine. They will generate a D-glucose. So D-glucose basically is just going through. But what's the key thing happen? Is right here. And this product is very interesting, is this guy, NH2. This doesn't even change anything. Then you go here, CH. Only this one. Acrylamide. The regulation in the United States for the chemistry safety standpoint, acrylamide has to less than 1.5 parts per million. 1.5 ppm. Why I want to say this? It happens all the time. Which product is a high amount of asparagine? Is potato. And the potato works with glucose at extremely high temperature. Heating. Let's say more than 120 degrees Celsius. Then what it becomes? French fries or chips. Or French fries. Then which product is dominant? Acrylamide. And what's a bad thing for that? Carcinogen could be theoretically will cause cancer. So what we have to do? So you know we have a different fast food chain like McDonald's, KFC, or those. There is a one store the kids all like, especially during the pandemic, and they have advertisement that said that their potato is really good. Number one is their organic potato. That's what they said. Number two, they do it a little bit special. The potato is pre-soaking in kind of like a heated water, not really hot, for 3 to 6 hours. And this whole process is called blanching. And this whole blanching process could reduce 60% of L-asparagine, which could be decreased the amount of acrylamide. So that's why the acrylamide generation I want to talk, because it's widely existing in the chips and the French fries. If the potato products at extended temperature and they start to heating, they will generate a carcinogenic material. Okay, so we're gonna end up with here. We talk all these things. The last thing we want to mention, we will talk at the beginning of next class. Non-enzymatic browning, we have Maillard reaction. So we have non-enzymatic browning. We have Maillard reaction. This is everybody knows, we just talked. What the other reaction is non-enzymatic browning. When you go Starbucks, you said I'm gonna order a caramel coffee. Caramelization. It is also a non-enzymatic browning. What's the difference? Maillard reaction is amino acids with sugar, reducing sugar, let's say glucose. Caramelization, they don't even need amino acids. Or say the more broadly, they do not need, no need in nitrogen containing compounds. There is a 4 category. So we're going to talk about this at the beginning of next Tuesday. Okay? Then we follow the talk. On Thursday. Tuesday we have exam 1. Thursday we're going to talk at the beginning, talk about caramelization. And we're going to briefly review the Maillard reaction because there's lots of them. And then we talk about meat tenderization, which is Dr. Kenny mentioned a little bit, but we're going to go over more detail. Talk about the protein, amino acids, muscle food structure related to the meat tenderization. Okay? So that's all.
This will still be on the exam, right?
No.
No, so where are we stopped?
We stopped before this.
Okay.
This will, I don't think it's there. This will be you generate a question by yourself. It's going to be a class project because it's a little bit difficult. We'll start from here. So before Maillard reaction will be in the exam 1. It's open book, short answers. Okay.